Chapter 17, Assembly Drawings. So what are we going to learn in Chapter 17? How to create an assembly drawing and how to create a standard parts sheet. Key points. Assembly drawings show how individual parts fit together to make a machine, and standard part sheet contains purchased items. What is an assembly drawing and why do we need them? An assembly drawing is a drawing of an entire machine or a system with all of its components located and identified. Typically, the old timers are the ones that I hear use the word machine. Nowadays, we just pretty much call it an assembly. And a good example of an assembly is a bicycle. So back in the good old days, typically you would order a bicycle or go to the store and buy it in a box. Not like nowadays where you can go to Walmart and it's already assembled. Unless you maybe order it through Amazon, you may have to take it out of the box and put it together. So in the good old days, this was referred to as a drawing of a machine being assembled. And that's an old school term. Now we just call it an assembly. Okay, we need to know how to put the machine together. The purpose of an assembly drawing is to show how the individual parts fit together. It is not used as a manufacturing print. So again, this drawing doesn't show how the parts are made. They have their own individual detailed drawings of how each tube is made, how each rim or spoke is made, etc. How the seat is made, that's a whole separate detailed drawing with instructions of materials and how it's formed or machined. This is an assembly drawing. It doesn't show any manufacturing, sheet metal, or machining. It's just instructions of how to fit all the pieces together to make your machine, or in this case, bicycle. Okay, so here's an example of an assembly drawing. Notice there are no dimensions. It just shows you how to fit the pieces together to make your assembly. Okay, so this is referred to as an assembly drawing. And this is your parts list. These are the parts that make up your assembly or your machine. Typically, when you list your parts, you want to go with the most important parts first, the large pieces. So item number 1 is the base. Okay, so here's balloon 1, and that's called the base. Quantity is 1, or required is 1, and it's made out of cast iron. So this is the material, cast iron. And let's go to item number 2, the fork. Item number two is the fork. So you go in order of pieces, either by their size or the most important pieces first. Okay, so the fork is the second piece. Balloon 2. The post, item 3, is the next most important piece. And number 4, we have the sleeve. Number 5, we have the bushing inside the sleeve. Number 6, we have a conical set screw. So this is a set screw that locks it in place. And notice on the conical set screw, we have 2 of them. So here's one set screw. Here's the other. And we also have a hex nut, quantity 2. So this is the hex nut here on the outside. And we have item 8, the set screw. Notice as we go down the list, the items keep getting smaller and smaller. So here's a little set screw. Again, a set screw is a screw with no head. That's so that you don't over tighten. And we have another smaller, even smaller set screw with a diameter of 7. Again, a set screw has no head, and that's so you don't over tighten and damage, in this case, the shaft. It's just to hold in place. Okay, so once again, always list the items from larger or most important down to the small stuff. Set screws are the least important. And you do, even though they're part of the list, they are the least important, and you always put them last. Okay, notice this is a third angle projection. SI is for metric system, and in this case we're using millimeters. Okay, so these M9s and M7s are metric diameters for the external threads, and these are the pitch of the threads, the distance between the threads, 1.25 and 1. And you can see most of the hardware is made out of steel, except for the bushing. The bushing is brass, and it's meant so that it doesn't gall, and also so it's easily replace once it gets worn down. Okay, here's another example of an assembly. Again, notice there are no dimensions. You can put an overall dimension just to give the assembler an idea of what size. You don't know if this is something that's 2 inches in size and height, or 2 feet, or 2 meters. So you can always put a dimension as a reference. Let's say it's 2 feet. You can put 2 feet in parentheses. Also, if you want to put an overall length, that's optional. And again, here we have our parts list. And again, you can work your way from the larger pieces, the movable jaw, which is item number 1. Item number 2 is the stationary jaw. And you work all the way down to the smaller items, the hardware, the bolts, nuts, washers, little jaw pin. Okay, always save the hardware for last. How do we show the size of an individual part? A detailed drawing is a drawing of an individual part which includes an orthographic projection and dimensions. So if we go back, if we wanted to know, hey, what's the size of this piece? What are the dimensions? What are the hole sizes? Then you would have to look at its detailed drawing. Same thing for the other pieces. You would have to look at its individual detailed drawing. And up to this point, that's what we have been creating, detailed drawings. And now we're going to be creating assembly drawings. All right, so here's another example of an assembly drawing. We have a front view, side view, bottom view. And you have your parts list. Again, you list the most important, the large pieces first, and you'll work your way down to the bolts, nuts, and washers. Typically, the washers are the least important, and they're typically at the bottom of the list. Notice balloons, you have a leader, and you have a circle. So these are referred to as balloons. One thing about leaders is you try and avoid having vertical or horizontal leaders. You're always going to want to give it an angle, preferably 45 degrees. If you can give it a 45-degree angle like this one. If you cannot give it a 45, then try a 30 or a 60-degree angle. And this one is close to horizontal. You try and avoid these type of leaders where they're close to horizontal or vertical. But because of crowding, you don't have a choice. But at least try and give it a little bit of an angle so you don't end up with the horizontal or vertical leader. Okay, so the parts list is an itemized list of the parts that make up the assembled machines. So when you're ready to put a bicycle together, you want to have a list of all the hardware and major components. So as you're putting your bicycle together, you want to make sure you're not missing a bolt, a nut, or a washer. Or you don't want to put your bicycle together and have leftover hardware like a bolt, nut. Later on something may come apart because you forgot to include a bolt or a nut. Okay, so it's always good to have a list of all the components, from the big components like the frame and the rims down to the little stuff like the bolts and nuts. Okay, let's go on to the next slide. Okay, let's take a look at the parts list. So here we have an assembly, a front view. Now the parts list, typically you will start, or I should say always, you start with 1 and work your way numerically. I want you to notice that this one is in the upper right corner, as mentioned here. It's in the upper right corner. If it's in the upper right corner, then you start with 1 and you work yourself numerically inward into your drawing. Now, it's very common that later on you may add some more hardware. So you create your drawing, and then later on you realize, oh, I need washers, or I need more hardware. Then you can keep adding to it. You can add item 10, 11, and so on. So you orient it in this way, so you can keep adding more items if need to, which is very common, especially on a very complex assembly, especially assemblies in aerospace. Another option is to place it on the bottom right corner, the lower right, but then you have to invert the table so one starts at the bottom and you work your way up numerically up to 16. And again, once in case you need to add washers, for example, then you can just add another row, 17, 18, and so on. So you work your way inward into the page so you can add more items if need to. Standard parts include any part that can be bought off the shelf, meaning that's something you can buy at a hardware store. You go to Lowe's, Home Depot, or stuff that you can order online from Amazon. They do not need to be drawn. So common off-the-shelf items, things that you find in a hardware store. Examples are bolts, nuts, washers, set screws. So common off-the-shelf items you find in a hardware store, you do not need to create a drawing. Back in the good old days before the internet, decades ago, you would provide a final sheet at the end of your package drawing. On the last sheet, you would provide an isometric view of the bolts, nuts, and washers with the specifications. But because now that everything's standardized, you can order stuff online and it'll follow a standard. So a simple example is McMaster, which I've talked about on previous lectures. If you go to McMaster, you want to order a bolt. This time let's take a look at a hex nut. We've looked at bolts already. So something that you'll be ordering a lot if you work in a machine shop or metal forming shop. So let's say I'm looking for a half 13. So half 13 means it has a major half-inch diameter and 13 threads per inch. So I'll go with the half 13. Okay, and grade. So you have different types of grades. If you're working in automotive, so if you're working on your car, maybe you're restoring an old vehicle, you want to go with grade 8 or higher. Grade 9 is available, but not as readily available as a grade 8. Grade 8 is more common. Okay, grade 9 is a lot better, but they're harder to find. So let's stick with grade 8. And this is the type of coating it has to protect it from corrosion. So we have zinc yellow. We also have black oxide. It's not 100%, but it'll at least slow down any corrosion. Okay, so let's take a look at zinc yellow chromate plated steel. And let's take a look at the details. So when you order something from McMaster, you can just provide the part number. So here's the part number. Okay, so when you place the part number in the parts list, anybody can look it up online. They can go to McMaster Car, and you can see the specifications, grade 8, thread size. UNC is Unified National Coarse Thread. So we're dealing with coarse thread. Class is 2B. 3 is preferred. 3 is the best. We have class 1, 2, 3. A is for external. B is for internal thread. And it also mentions any standards that it meets. All right, so let's go back to our lecture. Purchasing information is given on the standard part sheet attached to the back of the working drawing package. So we are not going to include a final sheet with bolts, nuts, and washers, but we will include them in the parts list. Okay, so working drawing package. Okay, let's take a look at an example of a Working drawing package. This is just an example. We're going to be doing our own by hand and not AutoCAD. Next chapter, we'll be doing it in AutoCAD. Okay, so we're going to create an assembly drawing for this machine or assembly. Then we're going to create detailed drawings of each individual piece and then provide a standard parts sheet, bolts, nuts, and washers. We're not going to include the final sheet, but we do need to call out the hardware. Okay, so first you start with an assembly drawing. Okay, so we have our assembly drawing, how the parts are assembled. Notice there are no dimensions. And we have our parts list. You call out the larger pieces first. So we have item 1, which is the base, right? Item 1. Item 2 is the weight plate. And item 3 is this pin. And item 4, we have 4 of them. We have snap rings holding the pin in place. So we have one on top and one here at the bottom. So the snap rings hold the pin in place so it doesn't fall out. And we use 2 of those snap rings. Okay, so this is the assembly drawing. So now if you want to look at dimensions, for example, the base, you need to go to its detail drawing. So let's go to the next page. So here's the detail drawing of that base. Dimensions, diameters. Okay, so you're going to do something very similar to this. Create an assembly drawing with a parts list, also referred to as the bill of material. And if you're ever working in a machine shop or metal forming shop and you hear somebody say bomb, they don't mean as an explosion. As a bomb, they refer to as the bill of material or BOM or parts list. Okay, so once again, here's the detailed drawing. This is the base. Okay, and here's the material made out of steel. And there's a total of 5 sheets. Again, we're not going to include the final sheet, sheet 5, which has the hardware. But we will call out the hardware in the parts list. And going back to McMaster, so let's say this was part of your parts list. You would just have to say McMaster car, part number, and the size of the bolt. 1/13. So once again, McMaster, part number, and finally, the thread size. That's all you would have to list the parts list. Maybe even call out the material. Okay. So once again, if we were to include a hex nut in this example, we would place item 5, hex nut, car lane, and the part number, and the quantity and the material. And you would also call out the thread size 1/13 for the hex nut. Okay, so once again, here's our detailed drawing of the base. Now let's look at the plate. Not sure why it's in red. So this is the drawing straight from our textbook provided by the author, the publisher. Okay, so here is the plate. It should be in black and not red. Okay, so here's the detailed drawing of the plate. Here we have the weight plate, sheet number 3, item number 2 made out of steel, sheet 3 of sheet 5, and the scale, is it full scale, half scale? We're drawing it as actual size, so we're drawing it as full scale. You can write in full scale or 1:1, and we need a quantity of 1. Okay, so now let's go to the next page, the pin. Now the pin is not something that you can order at a hardware store. I mean, you do have pins that you can order at the hardware store, but in this example, this part is custom made. So in this example, the pin was not available at the hardware store as far as the dimensions we needed. So we have to get a machine shop to make this for us. So since this part doesn't exist at a hardware store, it doesn't meet our needs, our dimensions. So we have to custom make one and give it to a machine shop, provide a drawing with dimensions so they can machine it for us. And finally, the last page would be the bolts and nuts. Let me show you an example. So if you were to include a a sheet with the hardware would look something like this. So I'm not going to ask you to do one for our assignment. But again, decades ago, in the good old days before the internet, you would have to provide a final sheet at the end of your package. So it would be sheet 5 with the bolts, nuts, and washers and all the specifications. What material you're using, the size, provide an isometric view. Okay, so once again, we're not going to draw this page. Okay, so let's take a look at your assignment. So for your assignment, I'm going to email this to you. Again, no AutoCAD for Chapter 17. We will be using AutoCAD for assembly drawings in the next chapter, Chapter 18. All right, so here we have an assembly. You can see we have 4 major pieces and we have some hardware, flathead screw, we have a bolt, and we have some hex nuts. Okay, so this is our assembly. And this is an exploded view. We are not going to draw exploded views. It's too much, it's time consuming to have to draw this up. Maybe in the good old days, yes, we would draw exploded views, especially before AutoCAD, before computers. Manually, you would draw something like this for clarification. But because we have CAD now, we don't draw exploded views by hand anymore. It would take up way too much time. Okay, so you're going to look at this part. So this is your assignment. Take these pieces. So this is an exploded view, so you can see all the hardware and all the pieces. Okay, so let's go to the first part, the base. So this is item number 1, base, and it's made out of 1020 steel. So you would place this in your parts list. So if you go to the next page, here's our parts list. You would call out item 1. The part name is base. And we need a quantity of 1, obviously, quantity of 1. And the material, 1020 steel. Okay, and let's go to our next item. We have this end bracket, item 2, the end bracket. Okay, so we would place item 2 on the second row, item 2. The name of it is end bracket. And we need a quantity of 2, so we have 1 on each side. Okay, so this is the same part. We have a quantity of 2. And for the material, we would use 1020 steel. Okay, and so on. You would fill out the parts list based on the information in the exploded view. Okay, so this drawing is already started for you, so you're not going to draw this from scratch. On the handout, this is already started for you, but you are to complete the assembly drawing. Okay, so the assembly drawing, complete your bill of material or your BOM, B-O-M, or your parts list, right? So fill out all the information from the exploded view. So get all this data, put it in your parts list, and call out the balloons. So we know the base, here's the base, that's balloon number 1. The end bracket, that's number 2, and here's the other end bracket. So this is also balloon number 2, and so on. Okay, so fill out the balloons, fill out your parts list. And by the way, this is a section cut. So we are cutting through this part. This is a section cut. So you are to also do some hatching. Let's take a look at the answer key. So I'm going to email you the answer key. Okay, so here's the answer key, the parts list. The balloons are filled out. And since we have a cutting line, a cutting plane here, so this line represents a cutting plane to expose the inside. So the front view has been turned into a section view. Okay, so we have the base, so it'll have its hatching pattern. So it's using double line at a 45. The end brackets are going to use their own hatching pattern. You cannot use the same hatching pattern for the base and the end brackets. They are different items, so you have to use a different pattern. So we are using the double line, and instead of 45 degrees, we're using 135 degrees. Now, since the end bracket is the same as the end bracket over here, then you do have to use the same pattern for the end brackets. It's the same part, so you use the same pattern. And finally, we have the middle bracket or middle plate. it has its own hatching pattern and it has a different angle. It's close to the angle of the base. The base has a 45. This one on the middle plate or middle bracket looks like it's at about 30 degrees. And you have to follow the same pattern throughout the part. Okay, so don't forget the hatching. A lot of students forget to do the hatching. I will take points off. I think this assignment is worth 50 points. That's a lot of points. All right, so let's go back to your homework handout. Okay, so once you complete your assembly drawing, now we're going to move to the detail drawing. So let's take a look at the base. So how do we get the dimensions of the base? You go to its detail drawing. Okay, so here's the detail drawing. It's incomplete. Most of it is there. So you are to complete the base detail drawing. Okay, so let's take a look at the answer key. Okay, so call out the size of the threads. You can draw double lines or you can draw one single hidden line. So you don't have to draw the double lines as shown here. It gets a little crowded, so one dashed line on each side will work. Okay, so don't forget to draw your tapped holes, which are these holes here. And don't forget to call them out. The thread size and the depth. So the depth is 20. That's the depth up to this point. That's the depth of the threaded hole, the tapped hole. And don't forget to insert any missing dimensions. Okay, so that's the base. So let's go back to the handout. So now we're going to look at the detailed drawing of the end bracket, and then we'll take a look at the middle bracket or middle plate. So let's go to the end bracket detail drawing. So here's the incomplete drawing of the end bracket. So all the views are complete except for the dimensions. So you are to place all the dimensions. Okay, so let's take a look at the answer key. Okay, so here we have the answer key for the end bracket. And don't forget to fill out the information at the bottom. So here's our author, drawn by Kirsty Plattenberg. That's the author of our textbook. This is the end bracket, sheet 3, item number 2. This is sheet 3 of 4. And we're using 1020 steel alloy. Scale should be 1:1 or full scale. And we're going to need 2 end brackets. Okay, so the 3 views are complete. The only thing that's missing are for you to place the dimensions. Don't forget to insert the dimensions on your handout by hand. And don't forget to call out the hole sizes. A lot of students forget the holes. Don't forget to call out this countersunk hole. And don't forget to call out the diameter of this hole. All right, so now we're going to move on to the next one, which is the center plate. Now the center plate, if we look at your handout, it's going to be blank. So you are to draw everything from scratch, front view, top view, side view. It doesn't have to be neat. So if you don't have a straight edge, hey, I want you to feel comfortable just doing it freehand. If the lines are crooked, I'm okay with it. I'm not going to grade on accuracy. I'm just going to grade on completeness. If your lines are all over the place, crooked, or if they're not exactly horizontal or vertical, it's okay. I'm not going to take points off. I just want to see your drawings complete. Okay, so this is what it's going to look like. Your front view. Don't forget your hidden lines, center lines. Again, hidden lines. Don't forget your hidden lines. So complete your front view, top view, side view, and don't forget to dimension. And once again, don't forget to call out the diameters of the holes. That's the one thing students forget, is to call out the diameter of the holes. Okay, so, and lastly, again, you don't have to draw this final page, a page of the loose hardware. Again, these are parts that you can find on in a hardware store, or you can order at McMaster.com or Carlane.com. Again, don't draw this part. Okay, so once you're done, take pictures with your smartphone or anything you have available to you and send me a JPEG, or if you want to scan it and send me your completed assignment through email. All right, so this is the end of chapter 17.